So next topic is derive the electromagnetic wave equation in terms of electric and magnetic field. So in the first case we are considering the electromagnetic wave equations in the electric field. So the wave equation for conducting medium, the Maxwell equation from Faraday's law in point form is given by, so del cross E equal to minus dou B by dou T, so B equal to mu into H. So these relations we have to substitute in the equations. So where del cross E equal to minus mu into dou H by dou T. Take curl on both sides. So del cross E equal to minus mu into del cross into dou H by dou T. So equation number 1. From Ampere's law in point form, we have to represent the equations del cross H equal to sigma into E plus epsilon into dou E by dou T. So differentiating on both sides, dou by dou T into del cross H equal to sigma into dou E by dou T plus epsilon into dou squared E by dou T squared. So that is the equation number 2. So substitute the equation 2 in 1. So del cross E equal to minus mu into sigma into dou E by dou T plus epsilon into dou squared E by dou T squared. So therefore the del cross E equal to minus mu into sigma into dou E by dou T minus mu into epsilon into dou squared E by dou T squared. So equation number 3. According to the identity, del cross E equal to del into del dot E minus del squared E, but del dot E equal to 1 by epsilon into del dot D, where D equal to epsilon into E. So we have the equations. So since there is no net charge in that conductor, so therefore the charge density is 0, that is rho equal to 0. By substituting these conditions, we have to obtain with the del dot D equal to 0, D equal to epsilon into E. So from this del dot E or E equal to 0. So therefore del cross E equal to minus del squared into E, equation number 4. Then compare the equation 3 and 4. We have to use with the del squared E equal to mu into sigma dou E by dou T plus mu into epsilon into dou squared E by dou T squared. So del squared E minus mu into sigma dou E by dou T minus mu into epsilon dou squared E by dou T squared equal to 0. So this is the wave equations in the terms of electric field. While you are considering with that wave equation in terms of magnetic field, the Maxwell equation from Ampere's law in point form, we can represent as del cross H equal to sigma into E plus epsilon into dou E by dou T. Take curl on both sides, del cross H equal to del cross sigma into E plus del cross epsilon into dou E by dou T. So this is the equation number 1. Now, so from this Maxwell equation from Faraday's law in point form, we can represent the equation del cross E equal to minus dou B by dou T, which will be equal to minus mu into dou H by dou T. Differentiating on both sides, we have to obtain dou by dou T into del cross E equal to minus mu into dou squared H by dou T squared, equation number 2. According to the identity, del cross H equal to del into del dot H minus del squared H. So from this equation, del squared H equal to minus mu into sigma into dou H by dou T minus mu into epsilon into dou squared E by dou T squared, equation number 3. But del dot H equal to 1 by mu into del dot B. Since there is no net charge within the conductor, the charge density is 0, that is rho equal to 0, del dot B equal to 0, del dot H equal to 0. So del cross H equal to del dot H minus del squared H. So from these equations, we have to represent del dot B equal to mu into H. So del dot B equal to del into mu into H equal to 0. So therefore these conditions we have to substitute in the equation del cross H equal to minus del squared into H, equation number 4. So del squared H equal to mu into sigma dou H by dou T plus mu into epsilon dou squared H by dou T squared. So del squared H minus mu into sigma dou H by dou T minus mu into epsilon dou squared H by dou T squared equal to 0. So this is the general wave equation in terms of magnetic field. So therefore we are discussed with that general wave equation for electric field and general wave equation for magnetic field also in the electromagnetic wave equation. So once again, the general wave equation for electric field is del squared E minus mu into sigma dou E by dou T minus mu into epsilon dou squared E by dou T squared equal to 0. So same way For magnetic field also, del squared H minus mu into sigma dou H by dt minus mu into epsilon dou squared by H by dou t squared equal to 0. So this is the general wave equations for magnetic field. Thank you.